take you through some string theory today. So, setting the stage a bit, in the beginning were the fixed encodings, and they were very simple. The idea was we're going to have one byte, one character. What could possibly go wrong? This is your ASCII, this is your Latin 1. Surely everyone would agree on what these things mean. Surely everything can fit into a single byte. Now, there was a bit of a revelation in the early days as people realized that the rest of the world existed. It turns out that 256 is actually not a particularly big number. So the fixed encodings had the first problem, which is multi-byte misery. 256 is not enough to have Japanese in it, it's not enough to have Chinese in it, it's not enough to have quite a lot of languages in them. So this whole conception of one byte, one character was in fact nonsense. We ended up with characters spanning multiple bytes, sometimes lots, sometimes very few. It made a lot of people very sad because it was very difficult to get right. There was a second problem, even worse, which is conversion. Now, some of you may remember the days of having to convert between different character sets. There are no words for the misery involved in converting between different character sets. They will make you deeply, deeply sad in ways you did not previously know possible. So, the Unicode consortium came along, and they came to fix all our problems. Their idea was, we will fix this by having a single register of all the characters, all the things anyone could ever possibly need to write. And then we'd have encodings where you just encode these code points. One code point, one character, and it's the same worldwide. And this, well, that fixes everything, obviously, as you're about to find out. So, have any of you been to job interviews recently? Any hands up? Recent job interviews? Yeah, a few of you. Okay. So this is a classic job interview question. Can you reverse a string? Now, I really like this question because it's got a right answer, right? This is a yes-no question. You answer yes and then stare at your interviewer. But usually they'll then push you to go, okay, can you actually show me how to do this? Okay, fair enough. Well, in Python it's not too bad. You get a slightly odd-looking thing if you... oh, this is not a laser pointer. You get a slightly odd-looking thing if you try and call reverse, but it's fine. There's this other spelling where you can, like, slice with a negative step, and it gets you a string backwards. And, of course, if you put in the string B's, you get C back. Good. You're hired. And, of course, in Python 3, now that we have proper Unicode support, this all works even when you're using non-ASCII characters. So you put in pade, French mathematician, and what you get back is EDAP. And this works. It's all very simple, very nice. And then because Python is a deterministic language, if you try the same thing again, you get exactly the same result, except what do we have here? That is the same string in, but if you look carefully, you will find that the acute accent has migrated. We now have a string with a quote with an acute accent on it, followed by some letters. Something does not seem entirely right there to me. Let's have a look at this string instead. This is Devanagari, which is the way you write Hindi, the biggest language in India. We put that backwards. What is going on here, right? We've now got this mysterious circle shape at the beginning of the thing. If you look carefully, you'll find stuff above the line has got out of sync with stuff below the line in what we've got written there. This is very suspicious. But the big one I want to give you an example here is this is the flag of Sweden. I'm going to reverse this string. Has anyone got a guess what that will come out as? I did hear the right answer there. It is the flag of Spain. Does this seem reasonable to you? Because it doesn't seem reasonable to me. And if we dig even deeper, what is going on here, right? Apparently, the flag of Sweden is 2 characters long. What's going on there? If you put it twice, so we've got 2 flags of Sweden, the flag of Spain is in that string. Python says this has got a flag of Spain in the middle. And yes, if you slice it, you will get out the flag of Spain. What is going on? Also, what was with that French name, right? Is it 4 characters? Is it 5 characters? What happens when you slice the last bit off? Do you lose the accent? Do you lose the last letter? I did not doctor this. This is copied and pasted straight from IPython into this slide. Something sus. What is it? Well, problem number 1, combining characters. Now, remember when I said back in the fixed days, we had this thing where you could span multiple bytes for one character and it broke everything? Surely, Unicode would not repeat the same mistake. So this is 2 characters. This is a letter E, and then another character immediately after it which says, oh, by the way, go back to the last character you just printed and add an acute accent on the top. That is what happened with that string that we reversed earlier, only the acute accent then ended up on the apostrophe instead of the E. So this doesn't really work in the same way, right? Problem 2, normalisation. Why is it that that happened once when we tried that string, but not the other time? The answer is, there's 2 different ways of representing E with an acute. You can represent it as 2 different characters, or you can have it as 1. There is also an E with acute accent in Unicode. You can do either. You can convert between them. You can use this library Unicode data to go, I want the expanded one. You can go, I want the contracted one. But these are different strings. If you ask Python what these 2 identical looking things are, it will say they're not equal. You have no way of knowing they're not equal. They print exactly the same, but they're not. Has anyone used this library, by the way, Unicode data? A couple of hands. Okay, so this is in the Python standard library. This is considered essential enough that it is in the standard library so that you can use this to do strings correctly. I know very few people who know that this thing exists. Strings are hard. Problem 3, other languages exist. What was that Devanagari example earlier? Well, see, the thing about Devanagari is it's not an alphabet. It's what's called an abugida. When you're writing in Hindi, a letter is not a sound. It's a sound with a vowel. That's not k, it's ka. You can add stuff to it to change the vowel if you like. Add a thing underneath, now it's ku. Add a thing over the top, it's kai. Add this thing underneath, and it really does become k. These are represented as separate characters. So now you've got the thing where this has length 2 in Python. We've added something onto the end of that string to represent a shorter sound. If you truncated that string down to 1 character from 2, you'd get a sound which is longer out. So it's actually, like length, can work in the opposite direction to what it would actually mean. Problem number 4, emoji. Curious little corner of Unicode. What do we think the length of this is? 7 is the correct answer. This is woman emoji, join, woman emoji, join, boy, join, boy. This is 4 emojis with a magic character in between each one, which says, I've probably got 2 emojis next to me. Why don't you try sticking them together when you render this? Right? If you implement backspace wrong, and a lot of editors do, when you hit backspace after this character, you will slowly delete members of this family one by one. Do we know what this is? How many characters? What's the length of this? That is 2. This is an upwards pointing hand, but in yellow, like a Simpson, and a blob of white skin tone. These can be rendered separately, but Python says, put these together, like that yellow hand and blob of skin tone and this are the same picture. This time, there isn't a thing which says join them together in the middle, because why have one way of doing things when you can have 2? This is the flag of the Netherlands. This has length 2. This is region indicator N and region indicator L. So you spell with these region indicator characters the country code, and you get the flag out. That's why we had Sweden turn into Spain, because SEES. But this is, of course, political. Which regions do you include? All right. Show of hands. Who thinks there's without looking, there's a flag of Palestine? Raise your hand if you think there is. Not very many. Raise your hand if you think there isn't. Okay. Surprise, it's undefined. It is left to the font. You can send a flag to someone else, and whether it shows and what flag it shows will depend on the geopolitical positioning of whoever manufactured their phone. But wait, these are sovereign states. So where did this come from? Like, we can debate whether Wales should be a sovereign state, but it's definitely not right now. So how did this end up in the character set? Well, this is a completely different system as well. That is a black flag with a bunch of tags after it. Because why have 3 ways in representing the same thing when you can represent 4? This is 7 characters long. A black flag would be 1. If you had a Welsh flag at the end of your tweet and you're going over the character limit, you could delete the Welsh flag, insert a black flag, and Twitter would go, oh yeah, that's much shorter. You can tweet that now. What actually is a character? Like, I think I know what a character is. It's a single thing that you can print, right? Put aside control characters. It's a single thing you can print. But that's clearly not what Python thinks it is. Maybe strings in Python aren't lists of characters after all. But can we treat them this way? Well, yes. See, some languages, Python 2, C, really did treat strings as sequences of bytes. Python 3 treats it as a sequence of code points, but some languages, like Swift, treat it as a series of these things called graphemes. A grapheme really is one printable character. All those examples were single graphemes. All the examples I've given so far would work in Swift if you treat them as graphemes. And you can do this in Python. There is a library. You can import this library. If you call length on a flag, you will get a sensible number out. You can do sensible slicing. This is possible. It's very slow, and the algorithm for it is standard but really horrible, but you can do it. Question is, why did we choose not to do this for Python 3? If you know the answer, let me know. Sorry? Well, it's very slow because it has to compute it on the fly. If you had a better representation, you can make this fast, which is what Swift does. But it gets worse. This is Arabic. And Arabic works right to left. What is the first grapheme of this string, which, by the way, says ha, 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 ha? Is it this one on the right? Is it this one on the left? Do you go in logical order? Do you go in display order? How about if we combine it with this string? So we're mixing English and Arabic. Do you go left to right on the top row and then right to left on the bottom row? Does it depend on context? There are algorithms to do this, but I warn you, this can be stacked. You can have left to right runs inside right to left runs, inside left to right runs. And you often do, for instance, if you've got Arabic text with numbers in it, which work left to right. So, is it a sequence of characters? What is the sequence, right? What is the order of the characters in a string? What is a string? But also, what is a character? Does anyone know what this word refers to? AES. This is the original name for AES. This is a compound word based on the names of the authors who are Flemish. So this is a Dutch-sounding word. In Dutch, IJ is a single character. If you have it at the beginning of a word and it's capitalized, you capitalize both the I and the J. So what is the second character of this word? Is it I? Is it IJ? The answer is, it depends on context. This is not just a technical question. This is a social question. It depends on background. It depends on analysis. It depends on who you are talking to. Again, we have this digraph at the end here, where you've combined the A and the E. Is that one letter? Is that two letters? If you spell it backwards, which way round should it be? Because if you spell this backwards, the obvious answer is to have the AE digraph there. But really, do you think the backwards version of this depends on how you're drawing the letters? These questions are really, really difficult. Turns out there is no single coherent definition of a character. There is no such thing as a character. They are these undefinable, situation-specific things which we do not understand. And so what are strings? These basic elements that we have in every programming language that we think are really simple turn out to be like eldritch abominations, liable to drive a man to insanity to even bear their terrible form. Right? Effect on women undefined. We just don't know. Text is far more complicated than we give it credit for, and these are basically impossible to get right. So can you reverse a string? Well, fortunately, as an interview question goes, this one's nice and simple. It is a yes-no question. And I hope I have convinced you all that the correct answer is no. Thank you very much. I will take questions. What's wrong with just using graphemes then? You had the answer at the end. Because the order won't be correct. The ordering of graphemes are close, but if you have right to left text, the ordering of graphemes is not necessarily correct.
So what do we do?
I don't know. I'm here to complain, not suggest fixes. I mean, so like fundamentally, this is a really serious, difficult problem, right? And I'm not saying, ha, 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 Python 3 got it wrong. There may not be a correct answer. You can actually debate whether Python 3 is better than Python 2. I suspect it probably is, but it's not clear that any of these solutions are good solutions.
Okay, that was actually my question. You've raised lots of problems. Is there actually a solution that we're missing?
I would love to say there is. I think graphemes are an improvement. I think there is more things we could do to be getting this right, and I think it's worth considering using graphemes in your own code if you want to get this right. But I think the biggest takeaway for me is don't assume that things that seem like sensible operations on strings are. Be careful about what assumptions you make with strings.
Are there any packages or modules you'd recommend other than Unicode-data and Graphemes?
So depending on what you need to do, there are a couple of packages which do pseudo-normalization, which make Unicode strings look vaguely ASCII-y. I wouldn't display those, but if you wanted to do things like search, they can be quite useful as making something that is plausibly ASCII version of stuff, rather than trying to deal with the Unicode directly. That can be handy. Otherwise, graphemes, Unicode-data, as I recommend, make sure you normalize your strings, and also be aware that there are other things that don't work in a standard way, like lowercase and uppercase. There's another one that I've forgotten. Come up to me afterwards. I'll tell you.
Hey, what's UTF-8 and UTF-16, and why do I have to define it sometimes to make strings go?
Sorry, say again?
Sorry, what is UTF-8 and UTF-16 in this context, and why do I sometimes have to tell Python I've got UTF-8 or UTF-16?
Right, so logically, a Unicode string is a sequence of code points. UTF-8 and UTF-16s are ways of representing that sequence of code points as a sequence of bytes. So, yeah, it's a representation of a code point sequence as a byte sequence, and you convert in and out of them.
You mentioned the Unicode-data package. Does it also handle, or can you use it to handle homoglyph issues related to your questions around normalization, or is that not within the scope?
Sorry, homoglyph issues, you say?
So you mentioned at near the beginning of the talk, the issue with egraph has like 5 different ways of mentioning it.
Yeah.
Similarly, there are like several characters that look like a letter A.
Yeah.
Can Unicode-data disambiguate between them? And
sometimes. Unicode-data will normalize to a single form for the E acute, and for most characters which have diacritics on them, most sort of letters, that will take care of it. There are other cases where you have 2 glyphs that look the same, like the semicolon and the Greek question mark, which have the same form but are logically different. Unicode-data will still tell you those are different. Whether they are or not is actually a matter for you to decide based on your needs.
I think we can agree that maybe we can't reverse all Unicode strings, but we can probably reverse most Unicode strings. I'm curious specifically about your example of Rendell. There were 2 things, the I and the J, and the A and the E.
Yes.
If we properly reverse that string, would we preserve the A and the E, and we would preserve the I and the J in that order?
Well, for me, the biggest takeaway from that is there isn't necessarily a single correct reversed form of it. There are a bunch of different reversed forms of it, all of which you can individually argue to be correct. So it's not necessarily that we are doing something wrong with how we reverse it. It's just that is one answer, and it may not be the correct answer for a given situation.
How often do you reverse strings?
Oh, all the time. Reversing strings is obviously a bit of synthetic example. I use it because it highlights these problems. The deeper problem comes with questions like the length of a string and slicing into it. Reversing just makes it a good example.
If I wanted to wrap one line of text into many, where do I put the line breaks?
Sorry?
If I want to wrap one line of text into many, where do I put the line breaks?
Indeed, it's a really difficult problem. There are algorithms and papers and infinite things that go on with this. Partly it depends why you're wanting to break it. If it's for flowing text, then it'll depend on your font rendering. So there we are talking potentially about things like the actual width of glyphs, which is a more soluble problem because we're dealing with actual fonts, things we understand, images at that point. If you want to add hyphens, then it becomes much more complicated again. But there are algorithms to do this that you can, and there are implementations of them on PyPI. I can point you towards one if you come find me afterwards.
So if we were dealing in a situation where we've got, say, Python as the back end and we've got some other language as the front end, does that significantly complicate this even more, or?
So it can be. This is one of the things where it usually works well enough that most people ignore the problems and then get very surprised when it comes to bite you. For instance, one of the things you'll see in protocols sometimes is you'll talk about the index into a string. Is that an index into bytes? Is that an index into code points? Is it an index into graphemes? Is it something else? When I was copying and pasting some of these examples from the terminal emulator had got that wrong for that very reason. In fact, there was one example a few slides ago. See if I can find it. You'll see that it's got the word in there twice. Right? That is exactly because of a rendering bug, because the terminal emulator didn't understand the length of this string when I hit backspace. The language server protocol, if you ever use that, used for syntax logic in your editor, gives indexes as, if you encoded this line in UTF-16, what would be the word index here, which is close to the code point number, but it's not quite. So that's why you get, so yes, in short, usually it works well enough when you've got different systems communicating, but actually there are real edge cases you have to take care about, and they're often very undocumented because the authors of the system don't themselves understand the semantics of them, because the semantics are really subtle.
I think we've got time for one last one.
Thank you. How come you know about all this stuff?
Well, you've got to know these things when you're a king, you know. I found out from a friend of mine at Bloomberg. I did not work this out on my own.
Fantastic. Thank you very much.
Thank you.